Okay, this is over here. 970942 AS Mechanics, question 6A. Whoa, okay. So let's start. A car of mass 900 kilos is moving up a hill inclined at inverse sine 0.12 to the horizontal. The initial speed of the car is 11 meters per second. After 12 seconds, the car has traveled 150 meters up the hill and has speed 16 meters per second. The engine of the car is working at a constant rate of 24 kilowatts. Find the work done against the resistive forces during the 12 seconds. So we know, let's write down the given. M is equal to 900 kilograms. Sine of alpha is equal to 0.12. Sine inverse 0.12 means that sine of the angle equals 0.12. Okay? The initial speed is 11, so V initial is 11 meters per second. After 12 seconds, the car has traveled 150 meters up the hill, so we could say delta T is actually 100, it's 12 seconds. It's traveled 150 meters up the hill and has speed 16 meters per second. So we can say that the length of the slope, let's just say length of the slope, is 150 meters, right? This doesn't mean the height of the hill, and has speed 16 meters per second. So V final is 16 meters per second. And the power is equal to 24 kilowatts. What do they want? They want the work done against the resistive forces during the 12 seconds. So the first thing you can see is that we're relating velocity, initial velocity, final, and height. So we're relating potential and gravitational energy. And what does that mean? We're working with mechanical energy 1 and mechanical energy 2. Can we say they're equal? Obviously not, because obviously we have external forces. What are they? We have the resistive force, and you also have the engine force. Okay? So whenever we have forces, what do? We say that ME1 plus these plus the work done by these forces, so the resistance force plus the work done by the engine, okay, is equal to mechanical energy 2. Now we can find them all. Let's say expand this. We know ME1 is the same as U1 plus K1 plus work done by the resistance plus work done by the engine is equal to U2 plus K2. Let's start finding each thing separately, okay? U1 is 0. We're just going to cancel this to 0 because you're starting at the bottom of the hill, okay? So let's start finding K1 is equal to half mv1 squared, which is equal to half times mass time, which is 900 times v1 squared, which is 11 squared. Okay, so you get 450 times 11 squared, which is 54450. Okay, we can find work done by the resistive force. We don't know what we're trying to find it. Work done by the engine. We have the power for the engine, and we have the time the engine worked at. So isn't the work done equal to power times time? Because power is equal to work divided by time, right? So work is equal to power times time. Okay, so it's just power times time. So it's equal to 24,000. Remember to convert it to watts from kilowatts times the time, which is 12 seconds. So you're going to get, let's do it on a calculator, 24 times 12 times 1,000. Okay, 288,000 joules. Okay, U2, it's equal to mgh. The mass is 900, g is 10. The height is 150 sine, sorry, it's 150 times 0.12. Why? It's 150 sine alpha, right? But we know sine alpha is 0.12. Why did I do this? The common mistake for this question is that people will take 150 as the height. Why? Man, this is the hill. It's like this. 150 is the length of the slope. We know this is alpha here. So to find the height, I always tell you height is equal to the length of the slope times sine of the angle. And we know the sine of the angle in this case is 0.12. Okay, so it's going to be equal to 900 times 10 times 150 times 0.12. Okay, let's do this on a calculator. 9,000 times 150 sine, times 150 times 0.12. Because the sine, don't say sine 0.12, huh? Sine alpha is equal to 0.12, okay? So 162,000. Okay, these are all correct numbers, just making sure. And then we know that K2 is equal to also half mv2 squared. So it's equal to half times the mass 900 times v2 squared, which is just 16 squared. Let's do it. It's going to be 450 times 16 square. You get 115,200 joules. So let's start substituting. K1 is 5. Let me use a different color just so we can kind of see better. So 54450 plus work done by the resistive force, we don't know it. Okay, plus work done by the engine, which is 288,000. 288,000 equals U2, which is 162,000, plus K2, which is 115,200. Let's solve this equation. You're going to do 162 plus 162,000 plus 115,200 subtracted by 288,000 subtracted by 54,450, and you should get that the work done by the resistive force is equal to negative 65,520, no, 250, 65,250 joules. Are we done? No. Why? Because they said work done against the resistive forces. Against the resistive forces. We know that when we say against, it's equal to negative the work done by the resistive force. So it's equal to negative 65,250, which is equal to 65,250 joules. That's it. Okay. Please don't forget. When you're talking about the work done against, you need to know that that must be a positive answer. If you're talking about resistive forces, it has to be a positive force because you're saying against. It's always the opposite. Okay. Thank you so much for watching, and good luck in your exam.